This is Mr. Beck Does Your Homework, homework number 15, question number 1. First off, this first paragraph really does not belong there, so I don't know what happened there. But Sally applies a total force of 284 newtons with a rope to drag a wooden crate of mass 100 kilograms across a floor with a constant acceleration in the x direction of acceleration is 0.1 meters per second squared. The rope tied to the crate is pulled at an angle of 49 degrees relative to the floor. So this 284 newtons is going to be here, 284 newtons. That's the force that I'm pulling with. Calculate the total work done by friction as the block moves a distance of 34.4 meters over the horizontal surface. Well, the work done by friction is going to be the force of friction times the distance that friction moved. But how do I figure out what the force of friction is? On this case, I have a block, and it's got gravity on it, and it's got a frictional force pointing backwards, and it's got a normal force pointing upwards, and it's got this pull up at an angle, F pull. This is moving at a constant acceleration of 0.1 meters per second squared. Well, my force pull is made up of a force in the x direction and a force in the y direction. My force in the x direction is going to be what's balancing friction. Not balancing, but my force in the x direction is opposing friction. So Fx to the right and force of friction to the left. But my acceleration is 0.1 meters per second squared. I'm going to need that. Turns out that the net force on this block will equal the mass times the acceleration. And the net force is going to be my force x to the right minus my force of friction to the left. So there's my net force is mass times acceleration. Is Fx minus Ff. I'm really looking for Ff. So I can solve for Ff by adding Ff to both sides and subtracting my mass times my acceleration from both sides. So what I get is my Ff equals my Fx minus my ma. So now I'll get my Ff equals my Fx, which is going to be my force, this pull force, times the cosine of theta to get my x component, minus the mass of the block times the acceleration of the block. So for me, my force of friction is going to be my force of 284 times the cosine of 49 degrees, minus the mass of 100 kilograms times my acceleration of 0.1. When I do that, I will get myself a force of friction. Now that force of friction is not at an angle. That force of friction is directly opposite the direction of motion. So now when I have work as force of friction times my distance, I'm going to use this force of friction down here as my force of friction here. And my distance will be 34.4 meters. So my work is going to be my force of friction that I got from down here times 34.4 meters. And I've already taken care of the theta because that gave me the component of the force that my pull force pulling to the right. So that is how much work will be done. Now it says the work done by friction. Now be careful because the force of friction is in this direction and the direction that it's moving is in that direction. So those are opposite one another. So I am going to wind up with a negative number for my work. It's going to be a negative answer.